Um, yeah. So, both of you, we will continue practical 10, questions number 3, up until 3 p.m. only, yeah? 3 p.m. After that, we will discuss the answer. And then, after that, we continue your past year questions because I think the most important thing now is for your exam is your past year questions lah. We need to discuss. Are you looking for what? Plug? Yeah, we can use. I think behind you, there's free plug. But behind you can see, right? Can. Pardon? Yeah. Actually, maybe I don't know if each of these like working lah, but I think if you are more comfortable using the one, yeah, that is, I don't know. So next time, when it is 100% using, I mean 100% face to face already, then maybe if we already know the capability of each of this lab. But this lab actually had interview. This lab is one of the best. Only lab two. This is actually lab two and lab one. Yang I mean the specifications of dia punya system is better than the other lab. It is even better than the Cisco lab lah. Hmm. Map. Last time we got during the orientation, if I'm not mistaken, Mr. Harold and the admin already shared it lah. But I don't know if you are in the nah. Why you lost kah previous? You cannot find what? Toilet. What's the phone? I thought you took a long time, oh. Yeah. In this apa in this block I also not sure. But block A I know lah. Where's later lah. I think we can ask from Mr. Harold. The man. Mm, so, yeah, any of you have finished that practical? Yeah. How about Noel?
Um, yeah, actually, it's too hard for me.
Oh, okay. So I will share my screen. I will explain a little bit because I think the most important now is we discuss the past year questions for your exam preparations. For your practical, since you already done your assignment, then I think okay lah. If you understand a little bit what I am gonna share after this, then you try yourself later, then I think you can more understand lah. Questions number 10, questions number 3. This one. So this, wait, oh, I haven't record. Sorry. Okay. So the questions 3 for the practical 10, it asks us to rewrite the hash dictionary class by using open addressing with double hashing collision resolution. So these are the functions that we want to use. So this is the first hash function, this is the second hash function. Okay, I think yours one for Noel, you can get it correct. So first is get hash index, and then second is you write um, if the index is already occupied, then you return new index. So the checking is happening in the probe. So your probe functions, you didn't include your probe
Uh,
functions here.
yeah, haven't.
You haven't done lah the probe functions.
Yeah, haven't.
Okay, so here is, it is correct already. During the add, remember I gave you both these client functions. So it will call the add method from hash dictionary, which is the hash dictionary is for the from the double hashing package. So like I said last time, what you can do is if using the linear probing, you have this package. If you want to rewrite the hash dictionary, but for now it is using double hashing, so you need to um, copy paste this package and make it new package, which is double hashing lah. So that we are referring fully on the. So dictionary interface is, I think, the same with the previous linear, but the difference is in the hash dictionary. So what are the difference between the linear probing and then the double hash dictionary is, it is, you can see in the add, when we want to add new 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 items in the student list, and then we call the add functions. So this add functions is from this hash dictionary double hashing package. So in the add, we call the probe. This probe function is the one that will call the get hash index 2. Okay, so here, if the index that is generated in the first index here is still not occupied, then these functions will return the same index as the index here. But if it is already occupied, then it will generate new index. So we see what is happening inside the probe. So in the probe function, the second hash index, or by if Noel, based on Noel punya um, method name, get hash index 2. So in the get index 2, you can just see the code is just like this. It is similar with what Noel did lah. Okay, so in the probe functions, here is where we return the same index if that index is still null. Okay, so here is if the index is still null and then it is not occupied, then you return the old value. But if it is occupied, then we need to assign the old value with the new value that is generated by this index. Okay, so in the probe, what happened is the increment is the value of the second hash function. And then here, if the found is this function is searching for new index, or it will return the index, the old index, if it is not occupied. So if it is the initial value is found, so which is false. So if while the value still not found, then um, pardon, is in, hash in table index is in. Okay, wait, we check. Written in table. So what is in table? Okay, so this in table, its value is true if the entry is in the table. Okay, so we go to the prop again. So if the entry is in the table, but it's still there are another checking lah, even though the entry is in the table. So if the key is equal to the hash table dot get index, then the found is true lah. But if it is not, I mean, if the key is not equal to the key here, then the index is the index after the double hashing. So remember, increment here is the double hashing. So it will return the index after double hashing process. Okay, so After that, um, so I think you all need to debug one by one lah for you to understand more later. But it is enough if we know that this function, it will return the same index. Where is the add? Add. The same index when the value, when the index is still not occupied, and it will return the new index if the index here from the first hash functions um, is occupied already. So um, the one that you all need to modify from the first example of sample, which is in the linear probing, is first in the add functions. So in the add functions, you need to implement here the probe functions. So what is the functions of these probe functions? It return um, the same index if it is not occupied, and or if it is occupied, it will return the new new index after double hashing. So that is the difference between the add by using double hashing and the add by using linear. So in linear, we only have one get hash index lah. So after that, it is in the add, and then after that, probe, you need to create new function which is probe, and then during the locate also, during the locate functions, because during the locate, we also need to implement, not here, so this function locate, we also need to implement this double hashing because this locate is used when we want to add or remove the entry, new entry. So first is you need to modify add, and then you need to modify add function, modify locate functions, and then add probe functions in the hash dictionary for double hashing. Yeah. So that's why I think it is a little bit, memang a little bit hard for you lah. Because you need to rewrite the whole hash dictionary. Not the whole lah. Like I said, just modify the locate, the add, and then you need to add new probe functions. The probe functions, you can refer to this. Yeah, so this is the example of probe. Okay. So if you are not, if you want to try later, you can check here lah. Or do you both want me to copy paste and give it to you? Or you want to try by yourself for this problem?
Uh, Copy paste better, yeah, to
Yeah,
understand the code.
yeah. But later you must go through this, explore this, understand the each of the step lah. Because actually there another way to do this. It is based on the creativity of the programmer. But as long as you can produce the same result or output, it is better. It is good. So even though you have different approach lah. Save it to the first location. I think I will need to apalah, give it here. Sorry, not through the the pro. Okay, so this one, because some programmer also, when you get the skills, there are a lot of way of how to learn programming. One of it is by learning from the example. Probe function. Oh, okay, so this is the probe function. So remember, you just modify the add function, modify the locate function, and add this function to your hash dictionary class. Okay, and then after that you run your test double hashing. So here, um, the the size of that hash table is 13, and then the value that we want to enter is 1, 2, 3, 4, 5, 6, 7, 8. So they are 8 and 3. So if you remember the rate of our load factor, once it is occupied 0.5%, meaning uh, number of entry 8 over hash table is 13. So it is already 0.6. So if I'm not mistaken, once we want to add beta, um, 1, 2, 3, 4, 5, 13. So when you add item number 1, 2, 3, 4, 5, 5 or 6 during this addition of the 6 and 3, the table will be undergo the process of rehash because it's already more than 0.5 load factor. So if you are not, if you want to debug, it is like this lah. Okay, so debug. First, we want to add here, and then we check in the rehash. So this one is the rehash. Okay, so um, so if we want to add here, it's still not. We go through the rehash. Then second also no. Third also, this one is second. Okay, so third no. Fourth no. Fifth no. Six also no. Sorry. Okay, and then 7 also no. It only will go to the rehash when you want to add the entry number at. Okay, because the load factor is already over this maximum load factor is 0.5. So once you add the entry number at, it will make the load factor over than 0.5. So rehash will happen during the add. Okay, so that's why when you print, the table is double its size already. No, it's not double its size lah. I am not sure what functions the. It is based on the double hashing tu lah. From 28, 13. So how 13 become 28? We need to go see here. What is the process of rehash? Okay, so how it is. So you explore here lah. How the 13 become 28 in the process of rehash. So process of rehashing last time we have Hmm, hmm, I think there are various way of rehashing, but we check of how the process of rehashing in our slide first lah. Because if you want to, because if anything, or I mean, if it is asked in the exam, it surely will refer to our slide or in our notes, even though there are a lot of method of rehashing out there, but we always to check or refer to the whatever that is what is taught in the class. So rehashing. So it says here, at least double its current size. So there are a lot of way of rehashing, but the one that we have learned is this one lah. But this one, new size at next prime size. So you we need to for this one, logically, if we see this code, can see kan well. And Ferrari Kelvin lah. If we see here, it as the old it double the old size lah, the size. Okay, so get next prime. Oh, it I think it will get the next prime number after you add the integer. So for example, 13. 13 plus 13 is 26. And then the next prime number of 26 is 28. So that's why you are um, we are getting 28. Okay, understand how to get how to do the rehashing? Mm, if 13 plus 13 is 26, but 26 is not a prime number. So we need to find the next prime number to 26. If I'm not mistaken, wait. 26 is not prime number. 27. Okay, okay, let's see here. So if here is 29, because we passed 29 just now, and then even add 1 to make it odd. Yeah. Mm, mm, yes. Yeah. Okay. So is prime here? There are a lot of process here to check. Yeah, itulah. I also don't want to explain one by one lah. This all you all can explore lah. How to get the prime number. Yeah. The conclusion I think is first double the size and then more find the prime number to that is next to the 26. Pardon? Yeah. 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 I think that is the algorithm lah. But I think the the what you can conclude is the size of the rehashing it must be double of the current hash table, and then you put the because of the hash table must be in prime number, so that's why you need to find the next larger than the new double of our hash table tu lah, the size of the double size of the hash table, and then find the prime number that is next to that number that is actually prime number. So I hope you can conclude it the conclusion lah, you know lah, right? How about si Noel? You are quiet.
Okay.
So you know the process of hashing lah, but the most important thing is it must be double of the size lah, and then get the prime number. Okay, so I hope we all can explore it later if you have time. But we proceed to your questions 2D. But I think I will give you both time 30 minutes to try to answer whatever you can lah. 30 minutes. So we discuss on 4 p.m. Only this one question. So this question is referring to what? Oh, the one that I said just now, 2D. No lah, if you can finish up until 3, better. Because our target is to discuss as most as we can for today. So that because you don't have tutorial time. So I think this is good to practice or to train you both to answer exam questions. So up until 4 p.m. Try as most as you can from questions 2D until 4. For the questions 2D, the fixed front array, you already learned that in chapter 4. So if you want to find, if you forgot what is fixed front array, you can check again the chapter 4 lah. I think questions number 3 is easy. I don't know you lah, but maybe you can go to questions number 3 if you are stuck with 2D.
Hey everyone, in this video, I'm going to give you an introduction to big or not multiple potential solutions for a single problem. For example, you should consider how without running those constants are. So you can, for example, rewrite this as C1 plus C2 by calling the fastest growing term. You just get O to 0, and then we run a for loop for each do the same process. So look, just O of 1 and every time, or a constant setting up this for time t here, and then between these two O of 1s we have n times O of 1 because we have this line right here which takes O of 1, and we need to execute this line n times because we need to repeat this process, add.
Today, I'm going to teach you binary.
Adding here we have, and to find the big O C4 doesn't, the time it takes to execute this function, find sum, T2 is an array, and the first element of this array here, C4 and n times C5, and the faster growing term here is n times C5 because that term actually grows as n grows larger, but C4 doesn't change because it's just a constant. So the fastest growing term here is n times C5, and the second step is removing the coefficient, which is C5, And once we do that, we get n, and that's what should go inside the big O expression. So we get this is of n. So we just found that the time it takes to execute this function.
For example, you, Kelvin, Chuck, what else? So your full name lah, even though including your father's name. Yeah, based on your understanding of that code lah, what happened to your full name later? Okay, so 4 p.m. already. Mhm. So what questions? You can answer until what questions? 3. 3B. Okay, good enough. How about Miles? Oh, 3A. Okay. So we start with Noel first lah, 3A. So looking at these functions, what do you, no, sorry, method. So looking at this method, what do you think the purpose of this method?
Oh, first, it, first it creates a string variable, a stack variable.
Uh-huh. Yes,
Then
stack.
it traverses through the string input,
Mm-hmm.
and then if each character is a letter or it's n, it's not an uppercase letter, it will be pushed into the stack,
Mm-hmm.
and then it creates another string builder.
Mm-hmm.
Then while the stack is not empty, it will transfer the character from the stack into the another string, and then it return the another string.
It will what?
Uh, where?
It because after it create another string builder.
Or it will transfer the character from the stack into the another string.
Because what happened in that? Because during the stack it is push, during the another string it is pop. So what happened to that character?
What happened to the create?
To the character in the
Oh,
another string.
oh, it it add into the another string. Yeah, it like what, like how to say, insert. Yeah.
Insert.
Insert. Yeah,
Mhm.
append. Yeah. So if if like append A contains A, so if append and then another one like append B, it now contains A B. Yeah.
Okay. Okay. So how about Kelvin?
Oh, wait, I got an explanation.
Okay, wait. I think I
I something like this. I like the he gets the input. He checks each letter if it is a letter. If it's a letter and the stack doesn't have the letter, it will be pushed into the stack.
okay.
So they'll add all the letters will be added to the stack, and if the letter already added to the stacks, it will not add the letter to the stack, and
Okay.
and
Correct.
and then after all the operations, they will start to build a string. The string will be built using the pop, so the output will be in reverse of the input.
Yes. So that is the keyword
Yeah.
reverse. Yeah. Okay. Good. Okay. So yes, whatever you both answer just now is correct. So if we see this method, I think Noel left one important keyword. When it is in another string, it builds the word again, but it is in reverse
Oh,
because at first it
Oh,
is push,
and
and then when,
all the letters in capital letter.
yeah, yeah, all of that. Okay, let me explain one by one lah. Ah. Um, we can see in the line number 5 and number 6, it filter each of your character in your name. It only receive letter, and then it don't want to accept if that letter is already in that stack, meaning it don't want duplicate letter lah in your name. And then after that, it don't want to accept any space, because there's a character dot is letter, right? So it don't want to accept any space, symbol or number, because it only want to accept letter. And then after that, it will make all of that characters into uppercase. Okay, and then after that, in the line 12 and 13, in line 12, it is creating object lah for string builder. So in this another string, it will get all of that letter, but it is in the reverse way. So whatever that you put in the stack, in another string, it will reverse it back. So yeah, so the answer is correct. Both of you have answered correctly. So if you see the suggested answer is here. Sorry, I haven't shared my screen, right? Okay, so the suggested answer here, all of your answer is already in this, meaning maybe only Noel lah left 1 marks because you didn't mention about reversing string. Okay? No need actually, because the questions only ask you the purpose of that method. Okay, so here, if you see here, this is the questions 3A. Okay, so the suggested is the above written string reverse the input string and eliminates duplicate with spaces, digit, or punctuation, because it only accepts letter, right? And then all character are converted to uppercase. So it doesn't matter how you describe, but as long as you have mentioned about the reversing the string in another string object or instance, object, and then you have answer or you have mentioned about removing the space, digit, and punctuation, because we have that is letter method. Okay, so after that you mentioned converting all of the character into uppercase, all get marks only. Okay, okay, Noel.
Okay.
Okay, so we are giving mark based on the keyword, based on the relevancy lah. Okay, so sorry, I forgot 2D. 2D, I think it is a little bit maybe hard lah. So Kelvin, did you manage to answer 2D?
I answer a bit, but not sure correct or not.
Okay.
Wait.
Okay.
Very short. I'm not sure. Not sure if it's 6 mark.
Okay. Okay. So this can be accepted, but of course you can get less mark lah. But but your big O is a little bit not correct for fixed front, correct? because it is different. Fixed front array and the re-queue having different big O, but I will need to ask Noel lagi lah. So Noel, what is your answer for questions 2D?
So here is the fixed front array. So here is the
Create the function. Okay.
so this is the big O of 1, but this one there's a loop, right? So
Yeah.
I put it n times O of 1, and then lastly this one is O of 1. So if I simplify this whole thing, it becomes big O of n.
Mm.
My answer is it is less efficient. Previously in the what the link,
Mm.
it has a big O of 1 compared to this one.
Yeah, so correct. So that is the correct answer. Okay, Kelvin, your big O of fixed front is it is not big O of 1, it is big O of n. So how to get the big O of n is by whatever si Noel showed us lah. Okay? Yeah, for fixed front array. Big O of n is a fixed front array. But uh, for the link implementation, its big O is big O of 1. So if you are using fixed front array, the big O is big O of n. If you are using the link implementation that we used in question 2C previously, which is in the re requeue functions, it only needs big O of 1, meaning big O of 1 is better lah. Yeah. So, um, I think Noel answer is can get more marks lah, of course. For C, but Kelvin answer that saying that fixed front array will be less efficient due to having more steps is correct. Only the big O is not correct lah, because it is not, we both are not big O of 1. And if you see the suggested answer, okay, okay, so this is the suggested answer if you can see. Yeah. So the QADT in questions 2A, if it is implemented using fixed front array, I think both of you are lack of explanation of this. Okay, so when an item is removed from the front, the remaining items need to be shipped one place forward. So that's why these operations need the big O of n, because um, all of that item in the middle will need to be shifted one place to forward. So, but if we are using the link implementations, then only the item from the front and then only the reference for the first and last node need to be updated. So middle nodes are not required to shift, and then it is still there. It doesn't, meaning the operation on the process is lesser than the fixed front array. So the big O of it is big O of 1 lah. Okay. So yeah, so like what Kelvin said, a fixed front array will involve more operation and it will be less efficient. Okay, so I think for Noel, maybe you can get about 4 marks. Kelvin, maybe 1.5. My guess only lah, but yeah, based on the shortness of your explanation. But si Noel, because you only lack of the a little bit explanation lah about what is the fixed front array, what happened in the fixed front array, then maybe you can get 4 marks lah. But this is my just a glance through lah. This is not a details examinations lah. How I give marks. So question number 3B. So this one, because Kelvin up until here, you answer up until here. So what is your answer? 3B1.
Oh, I put in the chat.
Oh, okay. Okay, Shak can wait. So Noel, you haven't reached until this Sapala, right?
Oh, actually, I copy paste the code to the NetBeans.
Okay, then then what happened?
Okay lah, got the result lah.
Okay, so yeah, I also copy paste the code to the NetBeans to check. Yes, I think Noel, because I have tested your name previously, it is correct. IOONE. For Kelvin, we check first.
Our exam cannot check.
But this is for past Sapala. For past,
I know. Later exam cannot simply put code in to double check answer.
yeah.
Very scary.
Okay, so because imagine if the number of student 100 habis. Okay, so EYWNI, is it correct?
Yeah.
EYWNI. So it is incorrect. So for Noel,
AWNA, not NA, not. I can check again.
okay, EYWNI.
Wait, I in the last one.
Okay, so we check Shak
Oh.
can wait. Okay, so first, we manually. S is accepted, H, yes, A, yes, K, yes. And then remove empty space.
Oh, yeah, right.
Why?
I understand.
Because the A after the
Yes,
SH, right?
this is the second A. Okay.
Okay, so you both understand lah, because we don't have enough time, so I assume you both understand lah. Okay. So, si Noel answer, it is actually correct if I'm not mistaken, because I tested it previously. Okay, so Noel. Okay, so AILEO. So Noel, your answer is also incorrect lah.
Actually, the Lee is in front. Lee Noelian.
Oh, iya kan? That's why I remember previously I tried. It is the same with your answer. Oh, so your Lee Noel Lian lah, right?
Yeah.
Okay. So if Lee Noel Lian, yes, it is the answer lah. Okay. So you know how to get that lah kan? First, all of your name, you remove all the empty space, or because your name is, of course, don't have any numbers or symbols, so just empty name lah. And then remove the duplicate also. And then after that, you put it in the, because we put it in the stack, and then we move it again using pop, then we will reverse. After we reverse, we get only the character from 0 up until 5. Okay, wait. Yeah, because of here, character 0 up until 5. That's why you only take the the few name. So here, substring, it is actually 0 is inclusive, 5 is actually exclusive. Okay, so what does it mean is, for your start index of the character, 0 is inclusive in the substring, but 5 is not included. It is only up until 4. Okay, so if you remember, if you are using substring, it is actually not from 0 up until 5, index 5. It is actually up until index 4 only, if we put it like this. Okay, so remember, the n index is not included. It is exclusive. Okay, so question 2B. This one, anybody of you have,
I did a bit, not sure correct or not.
okay,
Uh,
yeah, you can show.
is it like this? Is it done like this?
Let's see.
I look online, for example.
Wait, it is little bit small.
Or I zoom in.
Yeah, so, yes, because we have different way. Actually, the suggested answer is having different way, but you your answer, your way is can be understandable. So you divide it in the sorted way and then unsorted array lah. So you, okay. So yeah, first yes E, and then after that you check it with the EY. So still EY in the sorted, and WNA still there, yes. And then EWY, because the next is W. So what's that? Oh, okay. So yes, correct. And then you take N and then you move it here. So yes, correct. Yeah, so I think correct. Your way is can be accepted. Can
Okay.
get. So how about Noel?
No, haven't done.
Oh, you're not done yet. Okay, so if you both can see, this is the suggested answer, but I think it is nowhere. Kelvin answer also can be accepted. Wait, I share my screen first. Okay, can see. These are the way. This is actually in our slide. Like it is following our slide, but using Kelvin way just now, I can understand. I think can be accepted. So this is the example of Tan Mei Mei. So different student, different answer, but as long as your way is correct, then can be accepted. So Noel, can you understand this part?
Yeah.
Okay, so we are using unsorted insertion sort for the, yeah, insertion sort in chapter at B actually. So we proceed. I think this one is a little bit hard. So anybody, of course, Noel, I know, not yet. Kelvin, also no. But I think um, all of the questions in this passive questions, I think this one is the most the most hard maybe. Sorted. Oh, yours is AEINO.
I don't use the table. I straight away the final answer.
Pardon?
I straight away the final sorted array.
Yeah, yeah. But um, yeah, I know this is the sorted, but yeah, but later in your exam, you need to show the step lah.
Yeah.
Yeah. Okay, so for your questions 3C, it is actually, if I try to answer this previously, I didn't find actually the way, the suggested answer. I mean, is it is not included in our note. Okay, so because binary search, how there are no diagram in our notes, if I'm not mistaken. Okay, so there are no diagram about how the binary search, but because of there are no binary, because here it asks you to draw a diagram, explain how the binary search is performed on a sorted array with 6 integer elements. So Um, the suggested answer, I will go directly to the suggested answer lah. Okay, so and then just and also assume this is our extended lecture from the previous, because we didn't. I think I didn't find lah. We didn't learn this previously in our class. Okay, so you just watch this to make you. Yeah, it is 3 minutes left. Okay. But let's say because you are free to choose whatever integer that you want, as long as it is 6 elements, and then you do the you set you let's say you can say lah, let's say you want to find number 60. So here it is 60, but in your example you can pick any number, you can sort any element, and then you can say that you want to find maybe 40 ka 30 ka 60, but in this case it want to find 60, number 60. So at first what it did is, this is, I think, the most important part lah. How to find the middle ID or the middle, how we divide that elements into two. So here, the the formula is first index plus last index and divide by 2. And then if it is not a whole integer or it is not integer, because 5 divided by 2 is 2.5, right? So you just take the integer. Don't round it up. Just take the integer. So that means you get only 2. So the value start is at index 2, which is 30. So since the 30 is 60, because we want to find 60, so 60 more than 30. So we can apa tu? We can ignore the left subarray. We can just focus on the right subarray, which is from index 3 until 5. Okay, so after that, we still cannot find 60. So we find another middle value. So how to get it is by same as usual, same as the previous, the start array, index of array, and plus the last array, and then divide by 2. So which is 3 plus 5 is that, then 4. So we can find 4 here, which is 50. Okay, so 60 is larger than 50. So we can ignore the left subarray. We just focus on right subarray, which is only index 5 until 5 lah, which is this only. So the last the last one is 5 plus 5 because the start and the end of the index is the same. So 10 divided by 2 is 5. So which is actually index 5. So it at the index 5 is 60. Okay. So therefore the target value has been located at index 5. So how you can get this is the correct calculation for MID. MID is middle ID. Okay. So if your example letter, you can, like I said, you can create any element of number as long as it has 6 number and it is in sorted array, in sorted way. Okay, because it is for sorted. And then correct way of searching subarray. So if you say that the correct way of searching the subarray is this one, search the right subarray. So from this, you need to search the right subarray also, not the left. Okay, so it is also 3. Okay, so so the clarity and correctness is 2 lah. Okay, so questions 3C2. Explain why the big O of the best case of binary search is big O of 1. Explain your answer with the example. Okay, so here it is 4 marks. Okay, so the explanation here is you need to give example lah. In the best case scenario, target item is found at the first search effort, meaning when you do this one, it is ngam. You don't need to divide again and again. So this is the best case scenario. Okay, so for example here, if the target is 30, if previously the target is 60, so you have this so your target is 30. So when you do your first middle, when you first search, it is ngam. The index that it point out is ngam to the target that you want to search. Therefore, the big O is big O of 1 because there are no, the step is very short. Okay, so hence, in the best case scenario, the target value will always be found in the first search. So no matter what the size of the problem is, okay, so no matter what is the size of your your array, if it is found in the first search, then the big O is big O of 1. Okay, so this can be understandable lah, right? So for question number, do you have can we extend our class about 10 minutes to 15 minutes? Are you waiting for your father kah? Tidak. You drive your own? Okay. So Noel, can we extend our class a little bit?
Okay, no problem.
Okay.
Raining
Because
outside.
I don't want to apa tu, have another class lah just for this. Okay, so for questions number 4, I think this one is easy if you remember our last lecture. Our last lecture is yeah. So this one. So this questions is given this binary tree, and then you want to remove H. So we have learned about when the node has no child, and then with the node that has 1 child, and then with the node that has 2 child, at most 2 child lah. So here this H has 2 child. So there are 2 ways. If you remember in our chapter 9, page 72. Chapter 9, page 72. If you all remember, you just need to draw that diagram again. Okay, so the first way, if that not have two child, so the first way is you take the um yes, the largest value of left sub tree. Okay, so the largest value of left sub tree, so which is 9. Then you replace with 12, so it will become like this. 9 is here. Okay, so the next way is you take the largest, the smallest value at your right subtree. So you get the smallest value at your right subtree. Okay, so here 19, you replace with 12. Okay, so remember, um, the largest at the left subtree or the smallest at the right subtree. So there are two ways. So the suggested answer is by using first method is you replacing H and then you take F. Okay, so if you see, you take F, you replace H. And then after that, second method is you take L. You take L, you replace F because it is, sorry, K. You take the K and then you just bring the child to K lah. Yeah. So the marks is based on the drawing that you draw lah. Okay. So remember, I think this is maybe one of the famous questions lah. Binary tree. Okay, Noel?
Okay.
Okay, so here. Questions 4B1. So this one, if you remember our last lecture using hash, when we are doing compute hash code for string, there are few methods that we have learned, but the one that is suggested is using Horner method. But I think in our class, I didn't explain why the first method is not really suitable. It's not really suitable lah. So, but here it asks why method 1 is not suitable. So, if you can guess why method 1 is not suitable,
Too simple.
pardon?
I can say they're too simple, can.
It is too simple, not really accurate. How about Noel?
It is not hashed properly.
It is not hashed properly.
Yeah.
Okay, so both are not a little, I mean, it is not really accurate. So this is, consider this as another extended lecture lah. Okay, so the reason is based on the method number 1 can actually lead to collision. Yeah. Okay, because the limitation, if for example we have these two string, it is different in the structure arrangement, but it will produce the same hash code. So it will create, it will lead collisions lah. So we don't want collisions. That's why we prefer the second method. Okay, understand?
Yeah.
Okay. So, questions 4B2. This one I think is similar with our practical last time, the one that Noel did. Okay, so the following is an example of 16-digit credit card number. So by applying folding technique, explain how to compute hash code for the above credit card number and convert it to a hash index. Assume the hash index table size is 2003. Okay, so what Noel did previously was through code. but it run the calculations here based on the human readable lah. Okay, so the suggested answer is something like this. Because the folding technique, I'm not mistaken, you need to add the folding technique set is, where's the folding technique? Here. Okay, so remember this one, folding technique, break the key into group of digit and then combine the group using addition. So how it did in the human readable, not in the coding way, is something like this. We add all of this number, we group it into four group, and then we add it, and then we to convert it to a hash code. To convert it to hash index, sorry, we need to perform um, the hash functions lah, which is here the modular. So remember, to do the hash functions, we need first get the hash code, and then after that baru do the hash function. So step one, get hash code. Step two, get the hash index using hash functions. Okay, so hash functions is the modular lah. Okay, so then you can get this one. So this is the index for number, for this number. Okay, so this one can understand. So as long as you can show the hash code using this uh, uh, folding technique, and then converting it to the hash index. So converting it to the hash index only 1 marks lah here. This one is getting more marks lah, which is 4 marks. Because here you divide it and then you sum up. So that is the folding technique. Okay, Kelvin? Noel? Understand?
Okay.
Okay, so the last questions. I think this one I need to ask you both lah, because this is, I think, the easiest questions in this past year questions. Provide a real-life computer application or system in which a dictionary entity will be appropriate. In your answer, explain what key and value will be stored in the dictionary. Can you both get the spontaneous answer for this? Noel first lah.
Okay, the real life computer application is to store the student details. So the student ID is the key and the
Okay.
value is the name.
Is the what? The name.
Name, yeah. Name, and then the student ID, I mean, the information will be inserted into the hash table depending on the student ID.
Yeah, so correct also lah. So that is the correct example lah. How about Kelvin?
Oh, can use book, book in the library. Use
So what is the key? What is the value?
the key is the book ID, and then the value is the name of the book.
Okay. So yeah, both of you are correct. It's just that in the value, actually, you can put more. Not only the student name, not only the book name. You can also assign an object to the value. So
The category can like that.
category.
Like category or gender, those things.
Yeah. So for example, if you assign object in your case, so maybe your object is book. So in the book, you have all of the information about the book, the character, the author. Okay. So for student, maybe the gender, the address, even the student name, all of the information about the student lah. Okay. So for example here. Okay. So address book in mobile phone can be stored using ADT. So the key will be the person name and the value will be the object of the person. Okay, so the object of the person is meaning the object itself lah. You can assign to the value. So it will have all of the information about the person. Okay, so object of the person, which is the name, email, phone number. Okay, so can understand here?
Can.
Okay, so good. Okay, so remember your exam is only 2 hours, and then if I understand it correctly, because I also never experienced face-to-face exam previously. So if I understand it correctly, the questions should be more easy than these questions lah, because this is open book questions. So the one that you face later may be easy, but you still need to do revisions, understand, for example, the binary tree lah. I think binary tree is popular lah, considering of how many questions it asks about the binary tree here. Even in questions 3B, 3C is also about binary search. Sorry, this one is binary search lah. It is not binary tree. Okay, so binary tree here, binary tree, I think you need to understand how when it is removed, when we only remove the leaf, when we remove only one child, it is all important lah. Okay, so make sure to understand the concept, even though it is easier, but you still need to do revision lah. Okay, so I hope you both can answer the questions in our in your. I hope both of you pass lah. Okay, I can see that both of you can from our previous class also. Most of you didn't manage to answer the last questions, because I think both you are answering the first questions first, kan? So my suggestion is, you before you start to answer, you glance through all of that questions first. Find the easiest. For example, in these questions, the easiest one is the last part, the last questions, kan? So if you didn't manage to answer that, you lose 5 marks already. It is sayang lah. Okay, so remember, glance through and then find the easiest one first. Okay, Noel?
Okay.
Okay, so after this, whenever I want to announce anything, I will use the Google Classroom. And
Okay.
if it is so important, I will message both of you personally lah. Okay, so good luck to your exam, and bye. If you have any question, you can ask me. Can ask me. Okay.
Okay, Miss.
Okay. Bye.
Okay, thank you, Miss.
Okay.